Shut up, Devin.
Hey, let's be nice.
He told me that I lose everything. Lose everything.
You let me correct his being mean, not you.
What is this?
All right, I asked you guys to be quiet. I am definitely not hearing quiet right now. All right, any questions on the homework? Yes. Number 8. Let's take a look at number 8. Number 8 says the following. Hey, Arson, you get 0 on this one. 4 steps, sorry. Number 8 is a triangular prism. Triangular prism. Right? We're told that this side is 4, that side is 4. There's a little square right here with a dotted line. I didn't make that very well. 2.8. And this side is 3, and this side is 5. There are 5 sides here. 2 of them are triangles. To my eye, it looks like the top and the bottom, T and BO, are the triangles. Then we have your 3 sides. You got a front that's a rectangle. You got a left. You got a right that's a rectangle. So the top and the bottom are triangles. Area of a triangle is 1/2 base times height. So I'm just looking at the triangle. Well, I got to look for the dotted line. The dotted line tells me with the square the base and the height. The square touches this side right here, which is not listed. It's way up here, 4. So 4 times 2.8. 4 times 2.8 is 11.2.
Yeah.
And I have to take half of 11.2. But someone, I believe it was Connor yesterday, said.
Oh, that you could, since there's 2 triangles, you can just skip the.
So these 2 put together are 11.2. Now you could take them in half if you want.
Really screws with
Okay.
Why is the triangle dotted? The first triangle dotted.
They're trying to mess with you a little bit on that one. All right, the front rectangle is right here. Is 3 by 5. That's easy. That's 15. The left one, a little bit hard to see. It's right here. Well, clearly it's 4 by this side. Well, that's 5, so that's 20. And then the other side, it looks like, well, it's also 20 because it's isosceles, this triangle. So we got 20, 20, 15, 11.2. Add those up, and that would be the answer.
What's your answer?
Well, add them up. Well, let's see. That's 40. That's 55. Plus 11. 55 and 11 will be 66.2.
I actually got the answer right. Holy moly.
And then units would be what?
Feet squared.
Feet squared. Okay. Anyone else?
My heart's gone. Number 7 is confusing.
Say again?
Number 7 is confusing just on the way it looks. Because it looks like it's tall, but then when you look at the middle for a couple of seconds, it looks like it's flat.
Agreed. So remember, that's the eye flipping thing that can happen if you stare at it longer than a few seconds. So you just have to be ready for that. Some people will literally draw rectangles off to the side so that they can, isolate it from the flipping that can go on. All right. Take all those, pass those to the left. Pass those to the left.
This was the one that I actually did.
Good, then you're gonna get credit for it finally.
But if I can't find it.
Oh, then you're gonna get 0.
Exactly. I lose everything. I'm an idiot. Sorry, I was mine.
Pass them to the left.
I lose nothing. It's a circle. Is there a unicorn? Your hair.
Okay, we have arrived, quiet please. We have arrived at the last lesson of the chapter. The last lesson of the chapter also deals with surface area of our last shape that we have to deal with, which is the cylinder. So our last shape that we have to deal with, now we've already done volume of a cylinder. Remember, it's the same basic formula as a prism. It's the base area times the height. The base area here is a circle, so pi r squared times height. So that is the formula for volume. Today we're not doing volume, we are doing surface area. And as you recall from our As you recall from our class earlier, calendar, nothing going on next week except tests. We'll review Monday, Tuesday. We'll take the test on Wednesday. So homework is a worksheet. Copy down, please. I will hand it out at the end of class. As you recall from our discussion of surface area from yesterday, the definition of surface area is the part that you can touch, the surface of it, of a three-dimensional shape. It's the total area of the surface of a three-dimensional shape. Okay, that's the definition of surface area. We've done two of them before. We've done rectangular and we've done triangular prisms for our surface area. Today we get our third and final one. It's the last thing we do in the chapter, surface area of a cylinder. Now, yesterday I didn't give you a formula for those two shapes. And the reason I didn't give you a formula, it's a little complicated, but I find that I want to get you to understand the concept of surface area. You add up all the shapes. That way, instead of just giving you a formula, you're not understanding why it's surface area. You get a better understanding of surface area. We have a problem with a cylinder is that the sides of a cylinder
Are circles.
It's not a circle, it's
Circumference.
I don't know, it's round, right? It's not a defined shape, right? So that becomes an issue. That's why this one I will give you a form. I'm going to explain where it comes from. It makes sense. But the we can't say, you know, top, bottom. Well, we can for the cylinder for the top and the bottom. But as soon as we get to the side, there's, well, I don't know what the shape is. It's just, it goes on forever as I spin it around. There's no edge to make it start or stop. So that becomes a problem until we see how we fix that problem. All right. So surface area. From the last class, surface area. It's the total amount of space on the surface of a three-dimensional shape. Okay. The steps we had yesterday, this was for the triangular and the rectangular prism. That was, we name our sides. Okay. 6 of them for rectangular, 5 of them for triangular. And the names we agreed on were top, bottom, left, right, front, back, or some semblance of those names. We identify what shape is the top, what shape is the front, what shape is the left side. And then we calculate the area for each one of those shapes. And then we add them all up. So it turns out that the formula that we're going to get for that follow these basic rules, except for the middle part, which I don't know what that shape is. That's a problem. I don't know what the middle is. Well, I mean, I do. We don't, it's not definable as we look at it. Okay, so we got to do something. Quick review, rectangular prism, following those 4 steps, we name the sides, top, bottom, front, back, left, right. We identify the shapes. Well, it's a rectangular prism, all the sides are rectangles. Not true for triangular. We get some triangles for triangular prism, as we did before we collected homework. We write down the formula for each one. It's length times width, and then we plug in those dimensions and we do that calculation. So for the top, the length is 12 and the width is 2. So 12 times 2 is 24. We repeat the nice thing about rectangular prism is the top is the same as the bottom, the front is the same as the back, the left is the same as the right. So yes, you're doing a bunch of calculations, but really you're just doing 3 calculations. You're doing them twice. Or you can just times it by 2. I mean, if you can remember that, you can certainly do that on the test. All right, if not, then you write down all 6 sides, you calculate the area of all 6 sides, and then you simply add them together. That's what your homework was. You had 8 of those last night for homework. Pay attention, both of you. Okay, so enough of the prisms. Let's go on to the shape of today, which is, so, oh, by the way, units will be squared because we're doing area. Volume is cubed, area is squared, both normal area, area of a rectangle, or area or surface area of a rectangular prism. So today we're going to do the cylinder. So here's what I need you to do. In box number 2, draw one. In box number 2, draw one. Remember, to draw a cylinder, step number 1 is you draw a squish circle. It's called an ellipse. Okay. Underneath of that, you draw another one, but the back side you make dotted. And then connect the sides. And if you're better than me, yours looks better than mine.
Actually, mine was.
Which would probably be all of you.
Nope. No,
Right.
except for me. No.
Okay, so there's your cylinder. We have parts of a cylinder. We will call the top and the bottom, not the top and the bottom, we'll call them Remembering from volume, we call those the bases. Okay? Our problem with this shape is the sides. There's no side. Like, well, yeah, there is. Okay, well, if I turn it a little bit, where is that side now? I don't know. I mean, the side of it is the same no matter which way I turn it. So we don't call it a side. We can't call it a face. We call it a side surface, except we don't use the word side. We call it a lateral surface. Lateral surface. So the sides of a cylinder are called the side of this. There's only one side. It's called the lateral surface, and it's not really a side. It's a surface.
Does this mean we do less calculations?
No, this one's will be the longest calculation. Or longest formula, I should say. The calculation actually isn't as long as what we did last night for homework. Okay, so those are the pieces, parts of a cylinder. So, okay, in this box, I'm going to describe where this comes from, the formula. All right, imagine if I had a pair of scissors and that I could cut this. I'm going to cut off the top and the bottom. What am I left with?
Well, you'd have if you laid it out, you'd have a rectangle.
Rectangle?
Well, if you laid it out flat.
If I cut off the top and the bottom, what did I just cut off?
The bases.
And that would be?
The cylinder.
If I cut off the top and the bottom, what would I cut off?
The bases.
The bases. And what would that shape be?
A cylinder.
Who said cube?
I think it was a tube.
If I cut off the bases, what shape did I just cut off? How many circles?
Two.
All right, well, there's your two circles, right? Okay. You're left with, if you cut off the top and bottom of a cylinder, what are you left with? A tube. Okay?
But if you lay it out flat, it's a rectangle.
If I lay it out flat, it's, well, I got to cut it up along the side. It turns into a rectangle. So that is what's going to help us calculate the surface area. Well, clearly this is that's squash, but it's well, we know the area of a circle. What's the formula for area of a circle? Well, how many circles do I have?
2.
So SA surface area, I'm not sure why I skipped box 3, but you can put it in either box 3 or 4. Don't write it down yet. SA surface area is this plus this, right? And you said this was what? 3, but the formula would be, but there's, so that would be okay. Agreed. There's an easier way of writing that. How many of them are there?
2.
Are they the same or different?
Same thing.
So I could write that as,
Here, square to the second power.
no, that would be multiplied together.
That's
Times 2. So in other words, I could write 2 pi r squared. Yes? Everybody with me? Richard?
Yes.
Okay. There's 2 circles, and each circle is pi r squared for area. Danny, yes? There's 2 circles, right? Rectangle. Well, I know the form for area of a rectangle. What's the form for area of a rectangle? Okay, length times width, right? So I need to add plus, don't write it down, length times width, but here's the problem. This is where you guys are lost because you kind of think like you're, pay attention, let's go.
I am.
Okay. So there is no length and width of a cylinder. I mean, they don't exist. There's no length or width. Yet I'm saying that if we cut the side open, it turns into a rectangle, and clearly that formula would be length times width. So what we got to do is we need to rewrite length and width to apply it to a cylinder. So I'm going to go back to this one more time. Here's my tube, yes? Which turns into a rectangle. Where is the length on this one? Top and bottom. So if I put it back into tube shape, where did the length go? And what would that be of this shape?
The circumference.
It would be the circumference of either the top or the bottom. It's the circumference. So the circumference is what the length is of a cylinder. Does anyone remember what the formula for circumference was?
We talked about it yesterday.
We did.
No, me and him.
Anybody remember?
That would be like 2 pi r.
2 pi r
Pi d.
or pi d, right? So 2 pi diameter. 2 pi r is the one that I'm going to go with. So length is now 2 pi r. You said the formula for area of a rectangle is length times width. Now I'm going to call length 2 pi r. Well, what's the width? There is no width of a cylinder. Where was width on the cylinder? Hold on, let's talk about one thing at a time.
On the bases.
The width was on the side. What's that of the cylinder? That is the distance between the bottom circle and the top circle. We called that the height, right? Think about this. If I roll this out the side, that becomes the rectangle. Well, the width right here would be the distance between top and bottom circle. We call that the height. So the width now becomes the height. So length times width is really circumference times height, or in other words, 2 pi r times h. That is your formula. Write that down. Okay, 2 pi r h. 2 pi r h. That is probably the longest form of 7th grade. Okay? Now, just so you know, if you open up your book right now, they write theirs in a different order. The book says 2 pi r h plus 2 pi r squared. It's the same formula. The reason why I write mine this way is because of my picture. When I broke it down, I put the 2 circles here and the rectangle here.
What does that S?
What else? Surface area. Yes.
So wait, for the circumference formula, you do 2 times pi times the radius?
Here is the formula that you will use. Circumference is just part of the area of the rectangle. So it's hidden inside right here.
So wait, you just do 2 times pi times the radius times the height?
Is that what it says?
And you don't really have to do anything with the circumference?
The circumference is hidden right here. There is the circumference, 2 pi r. Okay. What you're really doing is length times width of this rectangle. You okay? Yes.
Did you just do the circumference times the height and add the?
Agreed, but you have to write 2 pi r,
And
right?
then wait, do you add do you just do that, or do you add the area of the 2 circles?
What does it say to do?
Add the area of the circles?
Yes. And that's what the formula says. Okay, does everybody have the formula written down? Okay, in larger terms, how many letters are in the formula? How many letters are actually in the formula? Different letters. There's only 2. So you only need 2 bits of information to use this. You need what 2 letters?
R and H.
R and H. So I need the radius and the height. They will not mess with you with a cylinder. They're going to give you the radius and the height, or they could give you, Jake.
Or they could give you
That's the other thing they could give you, where the radius would be hidden. They could, instead of giving you the radius, give you the diameter. But you just have to divide the diameter in half. Okay, and they will do that. All right, put your pencils down, watch me do one. Hey, cylinders, it's the longest formula, but it's the easiest one to do. Because they can't mess with you. They're going to give you the picture of the cylinder. There will only ever be 2 numbers. Last night for homework, rectangle, triangle, prism, there are lots of numbers. And your eyeball was flipping around on you. You're like, well, where's the rectangle? I don't see it. They're only ever going to give you 2 numbers on the cylinder. So you got to identify the radius and the height. Hopefully you don't mess that one up. Hey, my radius is 4, my height is 10. Those are the 2 numbers that I toss in. Okay, we're still 4 steps. What's the shape? Cylinder. What's the formula? Step 2, there's the formula. Step number 3, plug in the numbers. Can you mess this up? Yeah. If you plug in the numbers in the wrong spot, you will get it wrong. But there's only 2 numbers. It isn't too bad. That's the radius, 4. That's the height, 10. So R's get replaced with 4. H, the 1, H gets replaced with a 10. See what I did? Okay. At this point, you're going to grab your calculator. Okay. If you have a dollar calculator, then you're going to use PEMDAS and be careful, right? That means you're going to square first and then do your multiplication. You're going to write the answer to this one right here. You're going to write the answer to this part of the expression here, and then add them together. If instead, however, you have this, a scientific calculator or a graphing calculator, you can literally type it in as it appears. Literally. Type the whole darn thing in. Your calculator breaks. You don't have a calculator. You got to do it by hand. Here's how you do it by hand. Everyone stop what you're doing and watch me. The first thing PEMDAS says is parentheses. Hey, well, there's parentheses, but there's only one number inside. Nothing to do. Then it says exponents. So we got to do exponents. This is not 4 times 2. This is 4 squared, which is
16.
Okay, see what I did? By PEMDAS, we don't do addition next. We do all the multiplication left to right. 2 times 16,
32.
that's 32 pi. 2 times 4, times 10, 80 pi. See what I did? 32 and 80 is a number. Then you multiply 112 times pi. You get your answer. Okay, grab your calculators. Let's do this. Grab your calculators. Let's do this. 2 times pi times 4 squared plus 2 times pi times 4 times 10. Notice I didn't say hit enter at all. Type that whole darn thing. Before you hit enter, look at your screen. Make sure it looks exactly like this. For those of you without the scientific calculators, then you got to do it individual pieces parts. You're going to have to do this piece individually, and then add them together. Further, if you have the graphing calculator, you're using the caret key for squared, and you got to use the arrow key, otherwise it stays up in exponents. For those with the graphing calculator, they know what I mean. The rest of you just hit your square button. If you hit the caret key, it'll stay up there in exponents. So let's do 2 times pi times 4 squared. Yeah. 2 or pi, either one, whichever floats your boat. Okay. For me, I always think about this as if I'm doing it with a dollar calculator, I'm going to do exactly this. I'm going to leave pi until the very end. So I'm going to do 4 squared is 16, 2 times 16 is 32. Then I'll do it through the second part, the second term right here. 2 times 4 is 8, times 10 is 80. Then I'll add 32 and 80. And then finally, I'll multiply by 3.14. That's also how I'll do it by hand. Did I lose anybody there? Okay. Did everyone get about 351.7? Now, I used 3.14. I didn't use the pi key. So yours is going to be a little bit bigger than that if you use the pi key.
I got 51.
That's what happens that's different between the pi key and the.
351.8583.
So that's the difference between pi and the pi key. Or 3.14 and the pi key.
Oh, yeah, hold up. I actually got that answer.
You should, because you use 3.14 like me.
Well, I guess I can use a dollar calculator.
All right. Are we okay with this?
Yes.
For those of you, Dave, we good?
Yeah.
Okay. All right. Box 5 is on your paper in front of you. See if you can beat me to it. Okay. Step number 1, we identify the shape. It's a cylinder. Step number 2, by the way, you want to know the hardest thing that will be on the test on Wednesday? What's this one asked me to calculate? But guess what the test is going to ask you to calculate? Area and volume. Part of the test will say calculate the volume. Part of the test will say calculate the surface area. If you think you're like, oh, I got this, I'm all over it, I know what I'm doing, and you don't read the instructions and it says calculate the surface area, instead you calculate the volume, congratulations, you did all that work for nothing. 0, right? Make sure you read, and it'll be clear, I won't try to trick you. There'll be a section on area, there'll be a section on volume, there'll be a section on surface area. Okay? Plus, we'll do 2 days of practice, and you'll hear me, berate you for 2 days about not screwing this up. Okay? I will make it, if you're paying attention, I will make it perfectly clear which section you're in. All right, let's see. Step number 2. Once you identify the shape, you write the formula, pi r squared plus 2 pi rh. Plug in the numbers. The radius is 2, the height is 6. I plug in the numbers. I'm going to do it by hand. If you have a calculator at this point, you just type it in your calculator. 2 squared, that would be 2 times 2 is 4. 2 times 4 is 8. 2 times 2 times 6 will be 4 times 6, 24. 8 plus 24 is 32. So that would be 32 times 5. This one isn't that bad to do by hand, by the way, if you follow my procedure right there. 32 times 3 is about 96. So it's bigger than 96, but not by much. For those with a calculator, you're taking that, and that's what you're typing in. 2 pi 2 squared plus 2 pi 2 times 6. What you get? Okay. Did you do the whole thing? You left off the H. You left off either the H or the R. You left off the R. 2 pi R H.
I'm not the exact right.
You have it written correctly. You just left off the R. That's the radius squared.
This is easy.
Squared plus 2 pi radius. It's okay. You can, okay, go ahead and type over 2 times 6. That's right. That's the answer. Maddie says it's about 100. What'd you guys get?
101, but I ran.
Okay. Now, she got more than that because she used the pi key. I used 3.14. We okay?
Yep.
Connor?
So with the dollar calculator, I just type in 2 times 3.14 times 2 times 2, memorize that number.
Or write it down better.
Or then I do 2 times 3.14 times 2 times 6.
Yes.
Okay.
And then add the two answers together.
Well, that's easy.
Did you use the pi key?
I used 3.14.
Well, I got the same thing as you were.
Really?
How many digits of
Maybe
pi?
I did use the pi key.
How many digits of pi does your calculator put into the pi key?
I don't know the correct answer to that because I've been told that it's different than the number of characters it actually displays. So it'll display a certain number of characters, but I have been told that when it does the math, it uses a few more, but maybe that's just, maybe it's true, maybe it's not. In terms of what we need to worry about, either one's fine, 3.14 or the pi key. What's up?
Wait.
Yeah. I think that was the difference, is that there isn't much of a difference for this one for pi key or 3.14. Yeah.
If pi is always getting bigger,
Pi is not always getting bigger. It stays the same.
Can you
It's
do
just
the
the decimals never stop.
What if somebody finds stuff?
Then things will fall apart in our universe because pi is irrational, right?
Wait,
Yes.
so wait,
No, pi's infinite, right?
Pi what?
Pi
you
is
don't know that
infinite.
for sure.
Yes.
What if somebody finds the end of pi?
Then, like I said, our universe collapses because pi goes on forever, never stops.
Wait, the universe would actually collapse?
No, I just said that.
Okay.
But mentally, yes. But yeah,
That's like
mentally-
finding out your name really isn't Connor, it's David. What?
No, that's more like finding out that human. Well, that's more like finding out something that doesn't make sense. Like,
That's like saying right now, if I drop this, it goes to the ceiling.
yeah,
Right?
like,
That would be bad.
2 plus 2 now equals
that's like
All right.
right.
Do box 6 all by yourself without my help. Go. Box 6 all by yourself without my help. Yes. Do box 6 all by yourself without my help. Why are you raising your hands?
Why does 2 plus 2 equal 4, but 2 times 2 equals 4?
That is called a coincidence.
coincidence.
I think not.
Because if that was a rule, then it would work for 3. 3 plus 3 is not the same as 3 times 3.
Because 3 is
2 is the only number that works with except for 0.
One
One times 1 is not the same as 1 plus 1. 0 plus 0 is the same as 0 times 0. So it is a coincidence that it works for 0 and 2.
That's funky.
Jake,
Is finding out, like, if we found out that pi had an end,
well, we won't, but
well, yeah, because like, would that be like the equivalent to doing prey, where you find find out your entire life was faked.
Yeah, that's the matrix, right?
Yeah, like how elevators they weren't actually going up. It was just like they put
You're-
in it, doors closed, and they changed the outside.
Right.
The outside was all just screens.
Yes. Now don't give yourself a headache by doing that much thinking.
And then there's aliens.
All right.
People that were like-
Do box 6, Jake.
Yep, sorry. Sorry about that.
What if you found out that the life was all a simulation?
That's when somebody says it's like the Matrix. That's what they mean.
No, it's not.
What if
It's not.
it's
What if
not?
you're not real? I'm kidding now. What if you're not real? There's no such
For those of you who've never seen a good movie, The Matrix is a pretty good movie.
I
Should
know.
I watch it? What's the Matrix? The Matrix.
Matrix is
Over
this.
out the window.
Is this Matrix is this idea that the reality that we think that we're living in is not the true reality. And I'll leave it at that. I don't want to spoil the movie.
It sounds like Inception, but a bit different. Like, okay,
At some point in your life, you will.
okay,
It's
it
a
sounds
good
like
movie.
it sounds like part of Inception, but a bit different.
Well, Matrix came out way before Inception. All right, time out. Time out. We're getting off topic here, myself included. All right, step number 1, we identify the shape. The shape is a cylinder. Step number 2, we write the base formula, pi r squared plus 2 pi r h. Remember what I said for those of you opening up your book this weekend. They write theirs as 2 pi r h plus 2 pi r. It's the same formula. Okay? We plug in the radius. We stop talking over me. We plug in the radius, which is 2. The height. The height is 3. Why is the height 3? Why isn't the height going up and down? Because the cylinder is turned on its side. The definition of height is not how tall it is. It's the distance between the two bases. Okay? And that in this case is 3. Doing it by hand, 2 squared is 4. 4 times 2 is 8. 2 times 2 times 3 is 12. 8 plus 12 is 20. So it's 20 times pi. Hey, doing this by hand was not that big of a deal. Until we get to the last step, we got to multiply 20 times 3.14. Okay, but I do know that 2 times 3.14 is 6.28. So this is 60, what? 62.8
Oh, wow.
centimeters squared. There is one way that I can mess with you. What is the only way on this that I can mess with you?
Diameter.
If I give you the diameter.
Oh, that was easy.
Box 7. If I give you the diameter, Danny said, well, step number 1 is, well, you don't wait to get the answer and divide by 2. You have to plug in the radius to the formula. Therefore, we have to take the diameter and divide it by 2.
That's not that bad, though. You just have
This
to
one's
look
not
at
that bad.
All
Yes.
you have to do is just half the diameter.
Let me finish class. We're just not
This
finished.
is 5 by 3, this has the-
All right. Stay with me. Box number 7. Stay
I'm
with
not telling you what I mean.
Carson. Stay with me. So the radius here is 2. The height is 6. We plug those numbers into the equation. And then we either do this by hand or with the calculator. If we're doing it by hand, 2 squared is 4. 4 times 2 is 8. 2 times 2 times 6 is 4 times 6 is 24. So I get 8 pi plus 24 pi. Well, that's 32 pi. 32 times pi is about 100-ish. And yes, this is the same problem as the previous one. No, as the front page.
Yeah, I thought I did
Hey,
something wrong.
The way you pass class is that you actually do the work. Okay? Get the practice, and then you'll be very confident you can do this. You have one problem left, and then we get to no more math class until next week. All right.
Yeah, the end of next week.
Do this one.
I did it.
Show me. Reaching into a backpack into a whole mess of goop. Madison, where's your stuff?
In the backpack.
Get it out.
I did it.
Get it out.
I didn't do that one. 'Cause I-
Do this
No, that'll
one.
be fine. It'll only
Do
take, like,
this one.
2 minutes.
Agreed. No argument there. Want to know the hardest part of this? because like I said, on the test, it's going to ask you volume and surface area. If you don't know the difference between volume and surface area and you're not paying attention, you might calculate volume when they're asking you to calculate surface area. And you'll be very, yeah, I know. Remember, the formula for volume is, what's the formula for volume, Caitlin? R squared times H. That's literally in this formula as well, too.
Oh, that's it?
Except it's not pi r squared, right? H, it's just 2 pi r. They sound almost identical, the formula for volume and surface area. But they're definitely different. So if you don't read it carefully and you're calculating volume, when they want you to calculate surface area, you get it wrong. All right, last one. Madison, what's the answer? We can all go to lunch.
Oh, it's 207.
Tell me what to write.
Oh, you're gonna put. Oh, all right. Yeah, you're gonna put 2 pi 3 with the square thingy
Okay,
plus 2 pi 3 parentheses 8.
go to lunch. Very good.
See,
Uh,
not stupid.
As you walk out the door, I will hand you your homework. Yes, I will collect your homework as well. No, grab it.
Oh, you didn't.
Sure. I can't believe it anymore. You're the always the second one. Cards fly off. I give it to Caitlin.
I never said turn in homework.
The fact that you came through the door and said, yeah, you did.
Jake, where's your homework? Where's your homework? There. End of the line. Where's your homework? End of the line. Turn your homework. Turn your homework. End of the line. Homework. Homework. With your last name? No, you're looking at the line. Homework. End of the line. End of the line. People that are doing their homework get the, do your homework. Get the privilege of leaving. People that didn't do their homework get the privilege of staying behind. All right.
I did do my homework.
Who? She had what?
Yeah, she had some.
What was the something? Who's squishy? Who stole it? It happened in this class? All right, the rest of you that didn't do your homework, straighten up my classroom. This is going to be
I
a
did my homework.
daily occurrence until you start doing your homework.
But I did do my homework. Just today.
All right.
But I did. Not for today. I just did
The PowerPoint you showed us?
I'm sorry that I did my homework, but I lost it. And I bet I'll give you $950 that I don't have. That I bet you. Our worksheet.
Now you may leave.
They got in trouble. Bad children.
Hey, Brad. Oh, seventh graders.
I was telling you, walking the hallway.
One time only.
Circle.
I still don't remember. That's true. She's like, you're gonna get over that.
Circle. Like I'm walking.